In a world grappling with the urgent need for clean and sustainable energy solutions, hydrogen fuel cells have emerged as a beacon of hope. These advanced technologies offer a pathway to a cleaner and greener future, promising to revolutionize not only how we power our vehicles but also how industries operate. Welcome to today's video, where we delve deep into the captivating realm of hydrogen fuel cells and their potential as a game-changing clean energy source. Imagine a world where our energy is harnessed from the most abundant element in the universe, hydrogen. Unlike conventional fossil fuels, the chemical reaction between hydrogen and oxygen within fuel cells produces nothing more than pure water and a whisper of heat. It's a remarkable feat of science that holds the key to slashing greenhouse gas emissions and breaking free from the shackles of fossil fuel dependency. But it's not just theory. Hydrogen fuel cells are making their mark in the real world. From the busy streets of metropolitan cities to the sprawling highways that connect nations, fuel cell vehicles are already hitting the roads. These vehicles offer the best of both worlds, long driving ranges and rapid refueling times, all while emitting nothing but water vapor. And it's not just personal transportation that stands to benefit. Public transit systems are adopting hydrogen fuel cells in buses and trains, reducing emissions and improving air quality for communities. But the journey doesn't stop there. Maritime vessels and even aircraft are exploring the potential of hydrogen fuel cells to revolutionize the way we traverse the seas and skies. But the reach of hydrogen's impact extends far beyond transportation. In the heart of industries, fuel cells are transforming the landscape. Power generation becomes cleaner and more decentralized, offering a lifeline during peak demand and providing energy in remote corners of the world. The industrial giants are also joining the hydrogen revolution. Refineries, chemical plants, and factories are adopting hydrogen fuel cells to cut emissions and enhance efficiency. It's a symbiotic relationship where progress meets sustainability. Yet, challenges remain. The source of hydrogen, its production methods, the infrastructure, it all requires a synchronized effort to bring this vision to fruition. But with dedicated researchers, innovative minds, and a global commitment to a cleaner tomorrow, these hurdles are not insurmountable. Join us as we embark on a journey through the captivating world of hydrogen fuel cells. Discover how they're poised to reshape the energy landscape, redefine transportation, and reimagine industries. Stay tuned for insights into the challenges we face and the strides we're making, all with the ultimate goal of a more sustainable and harmonious planet. Welcome to the future of clean energy, powered by hydrogen. Hydrogen fuel cells are a promising clean energy technology that have gained significant attention due to their potential to address various environmental and energy challenges. They offer a way to generate electricity through a chemical reaction between hydrogen and oxygen, producing water as the only byproduct. This makes hydrogen fuel cells an attractive option for reducing greenhouse gas emissions and dependence on fossil fuels. Let's discuss the potential of hydrogen fuel cells as a clean energy source and their applications in transportation and industry. Advantages of hydrogen fuel cells. Zero emissions. One of the most significant advantages of hydrogen fuel cells is that they produce only water and heat as byproducts. This makes them an environmentally friendly alternative to combustion-based energy sources that release harmful pollutants and greenhouse gases. High energy density. Hydrogen has a high energy-to-weight ratio, making it an efficient energy carrier. This characteristic is particularly important for applications where energy storage capacity and portability are crucial, such as transportation. Versatility. Hydrogen can be produced from a variety of sources, including natural gas, renewable energy sources such as wind and solar, and water through electrolysis. This versatility in production methods allows for different approaches to reducing the carbon footprint associated with hydrogen production. Applications in transportation. Fuel cell vehicles, FCVs. Hydrogen fuel cells can power vehicles, known as fuel cell vehicles, FCVs, providing an alternative to internal combustion engine vehicles. FCVs offer the advantage of longer driving ranges and shorter refueling times compared to battery electric vehicles, BEVs. Public transportation. Hydrogen fuel cells are being used in buses and trains, especially in regions where emissions reduction targets are stringent. These vehicles have zero tailpipe emissions and can help improve air quality in urban areas. Maritime and aviation. Hydrogen fuel cells have the potential to replace traditional combustion engines in maritime and aviation sectors, reducing emissions and noise pollution in these industries. Applications in industry. Power generation. Hydrogen fuel cells can be used to generate electricity in a decentralized manner. They can provide backup power for critical facilities, operate as grid-supporting resources during peak demand, and serve as off-grid power sources in remote areas. Industrial processes. Hydrogen fuel cells can be integrated into industrial processes, such as refineries, chemical production, and food processing. They can provide clean and efficient on-site power and heat, reducing the carbon footprint of these industries. Hydrogen refueling infrastructure. As hydrogen gains traction as a clean energy source, the development of a robust refueling infrastructure is crucial. Hydrogen refueling stations are being established to support the growing fleet of FCVs and other hydrogen-powered vehicles. Challenges and considerations. Hydrogen production. The majority of hydrogen is currently produced from fossil fuels, primarily natural gas, using processes like steam methane reforming. Transitioning to low-carbon or renewable hydrogen production methods is essential to realize the full environmental benefits of hydrogen fuel cells. Infrastructure development. Establishing a widespread hydrogen refueling infrastructure is a significant challenge, requiring substantial investment and coordination between governments, industries, and stakeholders. Cost. Hydrogen fuel cell technology is still relatively expensive compared to conventional energy sources. Research and development efforts are focused on reducing costs through improved materials, manufacturing processes, and economies of scale. Energy efficiency. While hydrogen fuel cells offer high efficiency when converting hydrogen to electricity, the overall efficiency of the entire hydrogen production and distribution process needs improvement, especially in comparison to direct use of renewable electricity in applications like battery electric vehicles. In conclusion, hydrogen fuel cells hold great potential as a clean energy source, particularly in sectors where battery technologies might face limitations, such as heavy transportation and industrial processes requiring high energy density and extended operational periods. However, addressing challenges related to hydrogen production, infrastructure, cost, and efficiency will be crucial for realizing the full benefits of this technology and integrating it effectively into our energy landscape.